What would happen if an object from the depths of interstellar space began behaving in ways no scientist on Earth had ever predicted? Stay here, because what is happening in our sky could forever transform our understanding of the cosmos. Just a few weeks ago, a telescope located in the heart of Mexico City captured something extraordinary, something that keeps astronomers around the world awake, searching for answers that seem to slip through their fingers like the finest sand.
My friends, welcome once again to this space where the stars tell us their secrets. I am Felipe Suarez, and tonight I bring you a story that I promise you will not easily forget. Have you ever thrown a stone into the air and expected it to change course on its own? Because that, in essence, is what we are witnessing with this cosmic visitor called 3I Atlas. Is it coincidence, or are we facing something that will rewrite the astronomy books forever?
The object known scientifically as 3I Atlas is not an ordinary visitor to our cosmic neighborhood. It was not born in our solar system. It did not form in the Oort cloud, nor in the distant Kuiper belt, those frozen regions where traditional comets that occasionally visit us with their spectacular tails reside. This object traveled distances that the human mind can barely conceive, crossing the void between stars for millions, perhaps billions of years, until it finally arrived at our small corner of the galaxy. And from the exact moment it was first detected, it began displaying behaviors that defy everything we thought we knew about comets and interstellar objects in general. Astronomers, accustomed to cataloging celestial phenomena into well-defined categories, suddenly found themselves facing something that simply did not fit into any of them. The most recent images, captured by a dedicated team of astronomers working from facilities in Mexico City, revealed something that left the international scientific community in a state approaching genuine astonishment. The trajectory of this interstellar visitor, according to the most precise calculations currently available, experienced an unexpected adjustment during its journey. Not a chaotic deviation caused by random forces of space, not a casual push from the solar wind that constantly bathes our system, but a precise change, almost millimetric in astronomical terms, that placed it on a direct encounter route with Jupiter's Hill radius. To truly understand the magnitude of this finding, one must first understand what exactly the Hill radius is and why it matters so much in this story. Imagine an invisible zone around any massive planet, a subtle and imperceptible boundary where the gravity of that world begins to dominate over the gravitational influence of the Sun. It is like its own territory, a gravitational realm that separates the influence of a planet from the influence of our parent star. Jupiter, being the undisputed giant of our solar system, possesses a truly enormous Hill radius that extends for more than 53 million kilometers in all directions from its center. It is a sphere of influence so vast that it could contain dozens of Earth-sized planets without the slightest problem. And 3I Atlas, after that mysterious adjustment in its trajectory, is heading exactly toward that invisible edge. Not near it, not in its general vicinity, exactly toward it. The observed precision is the kind that makes the most experienced astronomers stop what they are doing, review their calculations 2 and 3 times, search for errors in their mathematical models that simply do not appear anywhere. Because when the numbers match with such exactness, when observed reality aligns so perfectly with predictions that seemed impossible, something extraordinary is happening in the very fabric of our understanding of the cosmos. But here comes the part that truly keeps those who study these phenomena with professional dedication awake at night. That precise adjustment did not occur when we could observe it directly. It happened when the object was behind the Sun, completely invisible from any observation point on Earth, out of reach of any terrestrial or space telescope currently at our disposal. When it finally reappeared in our field of vision after that hidden journey, and scientists updated their orbital models with the new data, they discovered that something, whatever it was, had pushed the interstellar visitor just enough to radically and unexpectedly change its fate. The odds of this happening by pure cosmic chance are astronomically low. Preliminary calculations suggest a probability of approximately 1 in a billion, perhaps even lower. It is like throwing a dart from 100 meters away with your eyes completely blindfolded in the middle of a furious windstorm and still hitting the exact center of the target. That is precisely what this interstellar visitor has just accomplished before the astonished eyes of the global scientific community.
Do you realize what this means, friends? We thought a comet was simply a ball of ice drifting along, obediently following the laws of gravity like any other object in space. But 3i Atlas is whispering to us that perhaps things are not as simple as we believed. What type of natural force can produce that level of mathematical precision? Could there be something we are not seeing, something our instruments still cannot detect?
When a celestial object unexpectedly changes course during its journey through the solar system, scientists look for explanations within the framework of known and proven physics. The first candidate, the most obvious and best studied over decades of cometary observation, is outgassing. Traditional comets are composed mainly of ice, dust, and various volatile compounds that sublimate intensely when they approach the sun's heat. Those released jets of gas act as small natural rocket engines, pushing the comet in directions that may seem unpredictable to the casual observer, but that follow perfectly identifiable patterns for experts who have studied these phenomena across entire generations. It is a well-documented mechanism, observed and measured in dozens of comets over many decades of meticulous study. Science understands quite well how this process works and can predict its effects with reasonable precision in most recorded cases. But here is the fundamental problem with that explanation when applied to 3i Atlas. Natural outgassing produces chaotic and irregular pushes, not precise and directed adjustments. It is like trying to park a car by blowing on it with a high-power industrial fan. You could undoubtedly move it, but you would never manage to place it perfectly in the designated space, aligned to the millimeter with the lines painted on the parking lot floor. And yet, that is exactly what appears to have happened with 3i Atlas during its hidden passage behind the sun. The recorded push was of the exact magnitude needed at the precise moment of the orbital journey to place it on a trajectory that will culminate in March of the year 2026 with a close encounter at Jupiter's gravitational boundary. It is the kind of extraordinary coincidence that makes even the most skeptical and rational scientists begin scratching their heads with genuine perplexity at what they are observing. The observations made from Mexico City also reveal another deeply intriguing element that adds an additional layer of mystery to this cosmic enigma, keeping the international astronomical community on edge. 3i Atlas not only changed its course inexplicably during its hidden journey, it is also exhibiting a completely anomalous tail structure that directly defies established and accepted models of cometary behavior. Traditional comets, as many of you probably know, develop spectacular and striking tails when they approach the sun in their elliptical orbits. The intense solar radiation and constant stellar wind push the released dust and sublimated gas away from the cometary nucleus, creating those characteristic luminous trails that have fascinated humanity since time immemorial. Our ancestors saw them as celestial omens, as divine messages mysteriously written in the night sky by forces beyond their understanding. Today we know they are perfectly natural physical phenomena, the result of the complex interaction between cometary material and the radiant energy of our parent star. But 3i Atlas has something that very few comets have ever shown in astronomical records: an anti-tail, a tail that points directly toward the sun, not away from it as conventional physical laws dictate. This phenomenon, although certainly rare, is not completely unknown in documented cometary astronomy. It occasionally occurs when heavier particles remain suspended along the comet's orbit and, from a specific angle of terrestrial observation, appear to form a tail that defies the apparent logic of the solar wind. It is a visual perspective effect, nothing more complicated than that, or at least that is what it should be according to our current understanding of these celestial phenomena.
But here comes what has me truly fascinated tonight, friends. The anti-tail of 3i Atlas is too narrow, too defined, too stable to be explained by simple perspective effects. Do you know what it looks like when astronomers observe it? It looks as if someone had drawn a perfectly straight line with a very powerful laser across millions of kilometers of empty space. What known force can maintain something like that?
When a typical comet releases dust into the surrounding space during its approach to the Sun, that dust should disperse predictably following the laws of physics we know. The Sun's gravity constantly pulling, the sustained pressure of solar radiation pushing in the opposite direction, the small but significant gravitational perturbations caused by nearby planets. Everything contributes in a coordinated manner so that the released particles gradually spread in a wide and diffuse pattern over time. It is basic physics, celestial mechanics, that we have deeply understood and successfully used to predict the behavior of countless cometary objects for more than 3 centuries of systematic astronomical observation. But the anti-tail of 3i Atlas simply does not behave in that expected way. It looks ordered, it looks intentional, it looks as if something were actively maintaining those particles in perfect formation across distances that defy any human scale of reference. And that raises a deeply uncomfortable question for the scientific community studying these phenomena. What natural force can maintain such a precise and stable structure across such extraordinarily vast spatial scales? Astronomers from various institutions have proposed multiple theories to try to explain this disconcerting anomaly. Perhaps the chemical composition of the interstellar visitor is completely unusual, with types of exotic ice that sublimate in ways our current models still do not correctly capture in their equations. Perhaps there are intense magnetic fields involved in the process, complex electromagnetic interactions between the released cometary dust and the solar wind that our equations still do not describe with sufficient precision to explain what is observed. Perhaps the internal structure of the nucleus is so profoundly irregular, so radically different from any local comet we have studied before, that it produces perfectly directed gas jets creating apparently artificial patterns that actually obey natural processes we simply do not yet understand with our current tools. All of those are technically possible explanations within the framework of known physics. Scientists are working day and night at observatories around the world to rigorously test them, using every available piece of data, every image captured by terrestrial and space telescopes, every spectroscopic measurement revealing the visitor's chemical composition. But here is the fundamental problem keeping researchers awake. None of those conventional explanations fits perfectly with all the observations accumulated to date. Every time it seems like a particular theory works to explain one aspect of the mystery, a new observational detail appears that simply does not square with it, a piece of the cosmic puzzle that does not fit correctly with the rest of the picture we are trying to assemble. The dust distribution around 3i Atlas presents another additional mystery that has the most experienced specialists in cometary physics genuinely perplexed. In a typical comet from our solar system, scientists expect to observe a clear and predictable separation between fine particles and coarser particles released during sublimation. Fine dust, being considerably lighter, is quickly pushed away from the nucleus by the constant pressure of solar radiation. Coarse dust, being heavier and less affected by that pressure, remains closer to the object's original orbital trajectory. Over time and distance traveled, this gradual separation becomes very evident in observations made from Earth. But in 3i Atlas, this expected separation is not as clear as it should be according to established models. There are specific regions where fine dust and coarse dust appear homogeneously mixed, as if they had been released at the exact same time from the same precise region of the nucleus, but then behaved in completely different ways than expected by conventional physics. It is an observational pattern that directly defies our models of cometary dust emission in fundamental and troubling ways for those seeking simple and natural explanations.
And when I say it does not fit, friends, I am not talking about minor, small discrepancies we can adjust with a bit of advanced mathematics and some new parameters. I am talking about significant differences that force us to reconsider our most basic assumptions about how these objects from deep space really work. Could 3I Atlas be made of materials we have never seen before in any known comet or asteroid?
That possibility the host mentions is very real and deserves serious scientific consideration from the international astronomical community. 3I Atlas is a confirmed interstellar object, which means it formed somewhere completely outside the limits of our solar system. Perhaps it arose around a star very different from the Sun we know, a cold and long-lived red dwarf, or perhaps a blazing and ephemeral blue giant. Perhaps in a distant region of our galaxy, where the environmental conditions of temperature, atmospheric pressure, and chemical composition were radically different from those that existed in the primordial nebula that gave birth billions of years ago to our own cosmic neighborhood. If that were truly the case, then the interstellar visitor could contain types of exotic ice we have never had the opportunity to study in terrestrial laboratories, complex organic compounds that do not exist naturally on Earth or in any asteroid or comet of local origin we have analyzed, unique crystalline structures that sublimate in completely unexpected ways when heated by the intense light of our parent star. All of that could explain, at least partially, why the behavior of 3I Atlas is so profoundly disconcerting for our current models of cometary physics. But even generously accepting all those exotic possibilities, the central problem of the observed orbital precision still remains. We still have to satisfactorily explain how a supposedly natural object could adjust its trajectory with such mathematical exactness that it will end up passing through Jupiter's Hill radius in March of the year 2026. And that, honestly, is the hardest part for many scientists to accept. Not because it is physically impossible in absolute terms, but because it requires such a specific combination of factors, so extraordinarily improbable from a statistical standpoint, that it almost seems deliberately designed by some form of intelligence capable of calculating orbital trajectories with extreme precision. Jupiter's Hill radius, as we mentioned earlier, is an immense region of space with more than 53 million kilometers of radius from the center of the giant planet. It is a zone where Jovian gravity begins to clearly dominate over the gravitational influence of the Sun. For an object traveling through interstellar space at truly tremendous speeds, arriving exactly at that specific edge has no obvious purpose from a purely physical or natural standpoint. It is not a place where something special happens spontaneously, like a structural rupture from intense tidal forces, or a sudden thermal activation by some unknown mechanism. It is not a particular orbital resonance point that could gravitationally capture the object and turn it into a new permanent member of our solar system. It is simply an invisible gravitational boundary, an abstract frontier in the apparent void of space. And yet, 3I Atlas is heading directly toward it, with a precision that is almost disturbing for those who analyze the orbital data in detail. The speculative possibility that the visitor's trajectory was determined long ago, perhaps even before it entered our solar system, is certainly risky from an academic standpoint. But it is not completely outlandish when considered within the appropriate context of the observed anomalies. If 3I Atlas were an artificial object, or at least an object whose movement had been influenced by some type of advanced technology at some point during its long interstellar journey, then its trajectory could have been calculated and planned with extraordinary anticipation. It could have been specifically designed to perform a precise flyby of Jupiter, perhaps to use the immense gravity of the giant planet as an additional gravitational boost, a cosmic slingshot that would accelerate the object on its way out of the solar system toward a new unknown destination among the distant stars. It is a maneuver that our own space probes have performed dozens of times with resounding success over decades of planetary exploration. The iconic Voyager 1 and Voyager 2, those ambassadors of humanity now navigating alone through interstellar space, used Jupiter precisely for that purpose of gravitational acceleration more than 4 terrestrial decades ago. And if a hypothetical extraterrestrial civilization wanted to send an automated exploration probe across the galaxy, using giant planets like Jupiter to adjust trajectories and gain additional speed would be a perfectly logical and extremely efficient strategy in terms of energy consumption.
Do you know who is asking these uncomfortable questions from the halls of Harvard, friends? Professor Abraham Loeb, one of the most prominent and also most controversial voices in this type of cosmic debates. He is not a fringe theorist seeking easy media attention. He is a genuinely respected scientist with hundreds of publications in the world's most prestigious academic journals. And what exactly is he suggesting? Something that makes many of his conservative colleagues very nervous.
Professor Loeb, who directed Harvard University's Department of Astronomy for almost a complete decade, has publicly argued something that makes many of his more traditional colleagues feel deeply uncomfortable with the implications. Loeb maintains that objects like 3I Atlas, and before it the famous Oumuamua that visited our system in the year 2017, might not be completely natural in their fundamental origin or in their currently observable behavior. It is important to clarify that the professor is not categorically stating they are alien spacecraft crewed by beings from other worlds. He is not saying there are intelligent creatures from distant planets actively piloting them through the dark cosmos. What he is saying, with the caution proper to a rigorous scientist who values his academic reputation, is that the anomalies we are currently observing are so significant, so genuinely difficult to satisfactorily explain with the conventional physics we know, that it would be scientifically irresponsible not to openly consider all available possibilities. And that includes, however remote the statistical probability may seem at first glance, the possibility that we are observing something out of the ordinary. Something that could include, even as an extreme working hypothesis, technology of unknown origin created by some form of intelligence we do not understand. If Loeb is formulating these provocative questions from the prestigious chair at Harvard, and more respected scientists are beginning to admit, even if only in private conversations off the official record, that there is something genuinely strange about these successive interstellar visitors, then perhaps the general public should also keep an open mind to possibilities that previously seemed to belong solely to the realm of science fiction. But recent observations have added additional elements that further complicate the scientific picture and that deserve detailed consideration. According to the latest analyses conducted by multiple independent research teams, 3I Atlas does not fit comfortably into the traditional mold of a conventional comet in any obvious way. The images captured by the Hubble Space Telescope, the observations made by the European Space Agency's JUICE probe, the detailed spectra obtained from terrestrial observatories around the world, the unexpected X-ray detections at the object's position, the chemical composition analyses revealing anomalous metallic proportions. Everything forms a growing scientific file that dismantles piece by piece the conventional hypothesis that we are simply observing an ordinary interstellar comet made of ice and dust, like so many others we have previously studied. This is not sensationalist journalistic speculation. It is a growing body of rigorous scientific evidence that demands, according to several prominent researchers, an immediate reclassification of the object and a fundamental rethinking of our understanding of its true nature. Among the most surprising findings that have emerged from the intensive observations is the detection of X-rays at the exact position of 3I Atlas. X-rays are not simply sunlight passively reflected by an icy surface. They represent energy emission self-generated by some active process within or around the object. For a traditional comet to consistently and measurably produce X-rays, it would need to expel massive amounts of gas, that upon violently interacting with the charged particle stellar wind, would generate that high-energy radiation. But that is exactly the opposite of what observations reveal about 3I Atlas, which appears extremely dry and minimally active in terms of conventional gas emission.
Does that sound strange to you, friends? An object that emits X-rays as if it had its own power source, but that at the same time shows very little typical activity of a normal icy comet. What kind of natural object can do that simultaneously? The honest answer is that we do not know for certain, and that uncertainty is precisely what makes this story so fascinating for those of us who love the mysteries of the cosmos.
Detailed spectroscopic studies have revealed another deeply disconcerting aspect of 3I Atlas that deserves careful attention. The ratio of nickel to iron in the observed metallic fraction of the object is approximately 10:1. That specific chemical ratio is something much closer to manufactured industrial alloys than to the typical composition of a natural cometary nucleus, which is normally dominated by frozen volatile compounds and refractory mineral grains with very different elemental proportions from those observed. This anomalous chemical signature alone raises numerous red flags among scientists who study the composition of solar system objects and interstellar visitors. It is not what they would expect to find in a piece of primordial ice and rock, traveling between the stars for billions of years. The observed morphology of the object presents equally disturbing additional mysteries for conventional models. A well-defined antitail projecting forward toward the sun, with apparently collimated jets and a rigid frontal structure, simply does not fit the standard model of diffuse ejection of volatile material that characterizes traditional comets. Natural jets produced by sublimation tend to gradually disperse and show similar colors and compositions when they originate from the same nuclear source. But in 3I Atlas, observers are documenting jets with clearly different hues from each other. That is an unmistakable signal of significant structural heterogeneity that is very difficult to reconcile with the image of a homogeneous, icy nucleus naturally formed in some distant protoplanetary disk eons ago. The object's orbital acceleration measurements have revealed velocity changes that cannot be explained solely by gravitational effects from solar system bodies. In conventional cometary models, these non-gravitational accelerations arise from the sublimation of frozen volatile materials, which create a thrust similar to a very weak but sustained rocket engine. But that process requires significant mass loss and should produce a visible and measurable debris cloud around the object. In 3I Atlas, scientists are observing anomalous acceleration without a sufficient cloud of ejected material to justify the magnitude of the recorded orbital change. In simple terms, there is not enough visible mass being expelled to explain the observed acceleration effect. It is as if the object were being pushed by something we cannot directly detect with our current instruments.
Are you starting to see the pattern here, friends? Each new observation, each new piece of data collected, seems to add another piece to a puzzle that simply does not fit the image of an ordinary natural comet. X-rays without clear explanation, metals in industrial proportions, acceleration without visible mass to justify it. How many coincidences do we need to accumulate before we start wondering if there is something deeper happening up there?
The energy involved in the observed processes presents another formidable challenge for conventional explanations, attempting to describe 3I Atlas as a typical natural comet. The extensive and apparently collimated jets observed would require mass flows and a solar energy absorption area much greater than what a nucleus of 3I Atlas's estimated size could support if it was simply primordial ice. Speaking in practical and concrete terms, the amount of material that appears to be being ejected and the apparent velocity of that ejection would require energy sources or propulsion mechanisms that do not align in any obvious way with the standard cometary physics we have developed over centuries of observation. There is an important principle in scientific methodology that applies perfectly to this disconcerting situation. A single isolated anomalous point could have plausible alternative explanations within the conventional framework. It could be a measurement error, an incorrect instrument calibration, an erroneous interpretation of ambiguous data. But when anomalies begin to systematically accumulate, when we simultaneously have X-rays without satisfactory explanation, nickel excess far above normal, jets directed forward against all expectation, strongly negative optical polarization never seen before, unexplained acceleration without corresponding debris cloud, irregular photometric behavior, and successive orbital coincidences with multiple planets, the overall picture changes dramatically. The probability that this entire diverse set of observations can be simultaneously explained by a convenient combination of ordinary natural causes decreases drastically with each new anomaly added to the growing list. It is precisely this consistent convergence of anomalous signals that constitutes, according to several respected researchers, scientific confirmation that something genuinely unusual is occurring with this particular interstellar visitor. Conservative scientists who initially dismissed the more radical hypotheses, without much consideration, have begun to publicly admit that the most plausible explanation for the complete set of observations is no longer simply that of an ordinary natural comet of interstellar origin. This is not subjective opinion or media sensationalism. It is a rational and measured response to empirical observations that consistently accumulate in an unexpected direction. Among the alternative hypotheses proposed to explain the behavior of 3I Atlas, one stands out particularly for its ability to coherently reconcile the different observed anomalies. It is the hypothesis of multiple object release, which some researchers have informally dubbed the mini-probes hypothesis. According to this speculative but testable proposal, the observed primary body could be releasing multiple smaller objects, perhaps reflectors, perhaps exploration probes, perhaps structures of unknown function, that would create the peculiar observational pattern we are documenting. The calculations and models performed by several independent teams show that a swarm of macroscopic non-volatile objects released near the object's solar perihelion could produce exactly the observed anti-solar luminous trail that defies conventional explanations. Numerous geometrically aligned reflectors would appear from a distance, from our terrestrial perspective, as a continuous and defined trail rather than a diffuse cloud of scattered dust.
Does it seem too adventurous to think in those terms, friends? Perhaps yes, perhaps no. But the important thing here is that this mini-probes hypothesis generates specific predictions that can be verified or refuted with future observations. That is science in action, not empty speculation. If the predictions come true, we will have to take very seriously the possibility that we are observing something truly extraordinary.
This hypothesis of multiple object release fits remarkably well with several aspects of the currently available observational data set. A set of distributed reflectors would naturally explain the defined anti-tail pointing toward the sun. Lighter objects and heavier objects would respond differently to solar gravity, potentially explaining the observed non-gravitational acceleration without needing to invoke invisible massive sublimation. Multiple probes or reflectors would naturally explain the observed collimated jets and the documented color differences between the different structures expelled from the main nucleus. And if part of the released material consists of a nickel-rich metallic alloy, that would explain the unusual spectral signatures that have so puzzled chemical analysts. Furthermore, and this is scientifically crucial, this hypothesis generates specific and clear observational predictions that can be verified or refuted in the coming months. That is a fundamental requirement of any legitimate scientific hypothesis. If the anti-tail is associated with the periodic release of multiple objects, its visibility should vary predictably with the hypothetical delivery events to different planetary destinations. Modelers have calculated that a drastic drop in the anti-tail's visibility around a certain date would coincide with the end of a hypothetical delivery to the vicinity of Mars, and a resurgence of visibility near the encounter with Jupiter predicted for March of the year 2026 would significantly strengthen the validity of this controversial hypothesis. These are clear, observable, and verifiable predictions. Real science in action, not empty philosophical speculation about abstract possibilities. Professor Loeb, analyzing the Hubble images and preliminary data from the JUICE probe, has presented an interpretation that remarkably aligns with the idea of the swarm of released objects. He has publicly highlighted that the teardrop-shaped coma observed in post-perihelion images coincides perfectly with the predicted separation between 3I Atlas and a set of larger fragments, a separation on the order of 60,000 kilometers, exactly the length of the anti-tail in the Hubble observation, made on November 30th of the year 2025. Loeb has also pointed to the preliminary images from the JUICE probe taken in early November of the same year, which show a luminous halo and subtle hints of two differentiated tails around the main object. These images were captured shortly before the probe's closest approach to the interstellar visitor, and JUICE's scientific instruments promise to provide detailed data on composition, particle characteristics, and spectral information that could definitively confirm or refute the presence of macroscopic material detached from the nucleus. Before jumping to overly bold conclusions, it is important to honestly examine the natural alternatives that the scientific community has seriously considered to explain the anomalies of 3I Atlas. One discussed possibility is that the object is an exomoon, a moon gravitationally torn from some distant exoplanet in the remote past. This is theoretically possible within the framework of known astrophysics, but would require an orbital history that allowed the object's survival over billions of years of interstellar travel, plus a mechanism for the currently observed jet activity. The anomalous metallic composition and X-ray emission do not easily align with the expected characteristics of a typically naturally formed exomoon. Another considered alternative is that 3I Atlas is a planetary fragment, a piece torn from some rocky planet, destroyed in some distant stellar system. Such a fragment could in principle show high metallic content if it came from the core of a differentiated planet. However, the simultaneous combination of directed jets, X-ray emission, and non-gravitational acceleration without a visible debris cloud remains without satisfactory explanation in this scenario. The initial favorite hypothesis of many conservative scientists was that it was simply an extremely depleted comet, an object that had lost most of its original volatiles during its long interstellar journey. But the near absence of water, estimated at barely 4% of the total material, the extreme optical polarization never observed in other comets, the anomalous nickel ratio far above normal, and the self-generated energy emission make this hypothesis seem increasingly improbable as new data accumulates.
Friends, before I say goodbye tonight, I want to ask you something from the heart. If this story made you think even a little, if it made you wonder about things you normally do not wonder about, if it made you feel that spark of cosmic wonder we all carry inside, waiting to be ignited, I sincerely invite you to subscribe to the channel. There are many more stories like this waiting to be told, many more mysteries of the universe to explore together in the nights to come. I would genuinely love for you to accompany me on that journey of discovery.